Good morning. I want to thank the organizer for inviting me to talk about the science in relation in the area of flavonoids and various health outcomes. As has already been alluded to, flavonoids are a group of polyphenolic compounds that are derived from plant-based foods. There are several subclasses of flavonoids, and they are defined by different chemical structures. And subtle differences in chemical structures may actually affect biological properties. Those are the 6 major subclasses of flavonoids, and their main food sources. Isoflavones, as you know, the major sources are soy, and some of the cocoa products and also tea are the main sources of flavin 3-Os. Fruits and vegetables are the main sources of other subclasses of flavonoids. The berries, especially blueberries, has a very high amount of anthocyanins, and one serving of blueberries may contain about 400 to 500 milligrams of anthocyanins. The bioavailability of different classes of flavonoids vary substantially. For example, the bioavailability of isoflavones is about 30%. This is actually highest among the different classes of flavonoids. And the bioavailability of flavin 3-Os is about 20%. And for anthocyanins, the bioavailability is very low. It's less than 1%. So the bioavailability of different classes of flavonoids is directly correlated with the half-life of those compounds. And this highlights the importance and also challenges of developing biomarkers for intakes of different classes of flavonoids. As you know, flavonoids are very effective antioxidants. However, beyond antioxidant effects, flavonoids have additional biological effects. And in vivo and in vitro studies have shown that some classes of flavonoids can activate endogenous defense systems, modulate cell signaling pathways, and some studies have shown that flavonoids have anti-inflammatory effects, and also in vitro, in vivo studies have shown that flavonoids can inhibit intestinal glucose transporters. Clinical studies have shown that some subclasses of flavonoids, flavin 3-Os in particular, can improve blood lipids, reduce blood pressure, arterial stiffness, improve endothelial function, and reduce insulin resistance. Many epidemiological studies have examined the relationship between intakes of flavonoids and various health outcomes. So far, 13 large prospective cohort studies have evaluated the association between flavonoid intake and the risk of cardiovascular disease. This is a meta-analysis published a couple of years ago. In this meta-analysis, the authors summarized results from 11 large prospective cohort studies. The summary relative risk comparing the highest categories of intake with the lowest category intake is 0.81, and this is statistically significant. And the outcome for this meta-analysis is CHD or MI mortality. So overall, there is about 20% reduction in CHD or MI mortality comparing participants in the highest categories of flavonoid intake with those in the lowest categories of intake. However, the association was not significant for CHD incidence, and the association was not significant either for stroke mortality. Since that meta-analysis, a couple of additional epidemiological studies have been published. This is a very large study published last year in American Journal of Clinical Nutrition, and this study was led by Mike Connon from American Cancer Society. And this analysis was based on a very large database, Cancer Prevention Study 2 at American Cancer Society, and they look at prospectively relationship between flavonoid intake and cardiovascular mortality in this very large population. Overall, there is a significant inverse association between total and the subclasses of flavonoid intake and the reduced risk of cardiovascular disease mortality. What's interesting here is that it appears to be a significant threshold effect. As you can see that the benefit of cardiovascular disease mortality plateaued around 250 to 300 milligram per day of flavonoid intake. And the reduction in cardiovascular disease risk didn't go further with higher intake. The same threshold effect was found for different classes of flavonoid intake. Numerous randomized clinical trials have examined the effects of cocoa products and flavin 3-Os on cardiovascular risk factors. This is a meta-analysis published very recently in American Journal of Clinical Nutrition. And in this meta-analysis, the authors summarized results from 42 acute and chronic studies. When I say chronic studies, in most of the randomized clinical trials, the duration of the intervention was less than 18 weeks. So in this meta-analysis, the authors summarized multiple disease outcomes in terms of intermediate biomarkers. So overall, the interventions with dark chocolate, cocoa, or flavin 3-Os significantly reduce serum fasting insulin and insulin resistance measured by HOMA-IR. And also, the interventions significantly improved flow-mediated dilation, FMD, which is a marker of endothelial function. And also, the intervention significantly reduced blood pressure, especially diastolic blood pressure. And this is one of the relatively large, longer-term studies on dark chocolate versus white chocolate on blood pressure. So this study lasted for 18 weeks. During the intervention, 1 square of dark chocolate consumption significantly reduced systolic and diastolic blood pressure. In contrast, white chocolate didn't appear to have any effects on either systolic or diastolic blood pressure. And this is a meta-analysis of several randomized clinical trials of cocoa and the CVD risk factors. It's a bit difficult to say, but in those trials, cocoa intervention significantly improved FMD, which is a marker of endothelial function, and also significantly reduced systolic and diastolic blood pressure, although there is a significant heterogeneity across different studies, but the reduction in systolic and diastolic blood pressure was clinically significant. Several epidemiological studies have looked at the relationship between chocolate consumption and the cardiovascular disease. This is a meta-analysis of 7 prospective cohort studies on cardiovascular outcomes. This was published in British Medical Journal 2 years ago. Overall, there is a significant reduction in cardiovascular outcomes with higher consumption of chocolate from those cohort studies. Similar results was found for stroke. This meta-analysis was published last year in neurology, and there is about 20% reduction in stroke risk in the highest categories of chocolate consumption versus the lowest categories of consumption. A major problem in this kind of studies is that none of the studies distinguished dark chocolate from other type of chocolate. So it's very difficult to attribute the apparent protective effects of chocolate against cardiovascular disease to cocoa or cocoa-related flavonoids per se. And numerous epidemiological studies have looked at the relationship between tea consumption, especially black tea consumption, and cardiovascular outcomes. This is a meta-analysis published 2 years ago. And overall, there is a 8% reduction in coronary heart disease in the highest categories consumption versus the lowest categories consumption. But this was not statistically significant. So right now, there is no evidence that higher consumption of black tea was significantly reduced, associated with reduced risk of coronary heart disease. And this is a meta-analysis of randomized clinical trials of black tea as a beverage or extract and multiple cardiovascular risk factors. It seems that black tea consumption improved FMD. However, the number of studies was very small. And there is some evidence that black tea consumption reduced diastolic blood pressure, but this was not statistically significant. And black tea consumption doesn't appear to have any beneficial effects on blood lipids. Many studies have looked at the effects of green tea consumption on blood lipids. This is a meta-analysis just published last year in the American Journal of Clinical Nutrition. So in this meta-analysis, the authors summarized the results from 14 randomized clinical trials on blood total and LDL cholesterol. And so overall, there is a significant reduction in total and LDL cholesterol in the intervention group using green tea as a beverage or as an extract. And this was this reduction in total and LDL cholesterol was also clinically significant, 7 milligram per deciliter. One peculiar aspect of this meta-analysis is that one study contributed to 85% of the weight to the evidence. And this study was not particularly large. It was only 65 people in the intervention group and the same number of people in the control group. So it looks like something wrong with this meta-analysis. So I think this meta-analysis probably need to be redone to make sure that the weights of the individual studies to the overall pooled estimate is correct. We have been conducting very detailed analysis of various dietary factors and health outcomes, especially diabetes and cardiovascular disease, using 3 large cohorts from Harvard, the Nurses' Health Study, Health Professional Follow-up Study, Nurses' Health Study 2. We have collected very detailed information on diet and lifestyle on a regular basis every 2 to 4 years. And those repeated measures have distinct advantages because they allow us to reduce measurement errors and also represent long-term dietary intakes. And with those 3 cohorts, we have more than 300,000 men and women who have been followed for 20 to 30 years. And recently, we have developed very detailed, extensive database on flavonoid intake based on the updated USDA food composition database. And this is a paper we published last year looking at dietary flavonoid intake and the risk of type 2 diabetes in our 3 cohorts. And this is a very large study, very powerful study. We have more than 3.6 million person-years follow-up and about 12,600 incidence cases of type 2 diabetes overall, we found a significant inverse association between some subclasses of flavonoid intake and the risk of diabetes. In particular, there is a significant reduction in diabetes risk with higher intake of anthocyanins. And the pooled relative risk for the three cohorts for a comparison of extreme quintiles is 0.85. And this was highly statistically significant after multivariate adjustment for age, BMI, lifestyle, and the dietary factors. For total flavonoids, we found a relative risk of 0.90 and was marginally statistically significant. And we also look at the individual foods which are rich in flavonoids and other polyphenols. And many of those individual foods are associated with decreased risk of type 2 diabetes. The strongest association was actually found for blueberries. And as I mentioned in the beginning, blueberries are very rich in anthocyanidins, and the average portion of blueberries contains about 500 milligrams of anthocyanidins. And we conducted detailed analysis on several health outcomes in relation to blueberry intake. In our cohorts, approximately 2 to 4 servings per week of blueberry consumption was associated with 10% reduction in hypertension, 23% reduction in incidence of type 2 diabetes, 5% reduction in stroke, and 30% reduction in coronary heart disease. And those analyses, again, were adjusted for other dietary factors and lifestyle factors. And the results remain significant even after those very extensive adjustment. So just a quick summary of what I have just said about observational studies and evidence from observational studies and randomized clinical trials. As the first speaker alluded to, in most situations, we're not going to have large randomized clinical trials with heart disease endpoints. So in this kind of situation, the combination of large prospective cohort studies with shorter-term randomized clinical trials with intermediate outcomes, I think is very critical for making evidence-based nutritional recommendations. Based on the meta-analysis, there is now substantial observational evidence for the beneficial effects of intake of total flavonoids or subclasses of flavonoids, as well as flavonoids-rich foods, such as fruits and vegetables and chocolate, risk of chronic diseases, especially cardiovascular disease and type 2 diabetes. Of course, more research is needed to clarify whether this reflects beneficial effects of flavonoids or other dietary constituents. Based on the meta-analysis, multiple short-term trials have found potential cardiovascular benefits of cocoa products and flavin 3-Os on blood pressure, endothelial function, insulin resistance, but larger and longer-term trials are needed. As the previous speaker alluded to, there are several methodological challenges for epidemiological studies. First of all, numerous factors can influence actual contents of polyphenols in plants, including sun exposure, rapidness of fruits, storage, food preparation, industrial processing, and so on and so forth. And also, there are measurement errors in dietary assessments of flavonoid intake. The errors can come from multiple sources. Food composition database may not be accurate. The dietary questionnaire, of course, is also may need to recall bias and other sources of measurement errors. And as I mentioned in the beginning, the bioavailability of different classes of flavonoids varies substantially. So the intake levels are not equal to bioavailable dose. And so those challenges highlight the importance of biomarker research because biomarkers are not subject to the sources of measurement errors for questionnaires. Recently, we completed a study using metabolomics technology to measure urinary levels of polyphenol metabolites and look at whether those metabolites predict incidence of type 2 diabetes in our 2 large cohort studies. This is health study 1 and 2. We measured several metabolites of polyphenols, those metabolites from intakes of lignans, whole grains, metabolites of coffee intake, and the metabolites of several classes of flavonoids. So in this analysis, we found a strong inverse association between metabolized lignans and reduced risk of type 2 diabetes, and the results are very consistent between those 2 cohort studies. And the urinary concentrations of intranectin and estradiol, which are metabolites of lignans, associated with reduced risk of type 2 diabetes in a dose-response manner. We also found a significant inverse association between urinary quercetin level and the reduced risk of type 2 diabetes, primarily in the early stage of follow-up, in the first 5 years follow-up, and that association was not significant after longer duration of follow-up. So from these preliminary results, we concluded that urinary concentrations of lignan and coffee metabolites are associated with decreased risk of type 2 diabetes. Urinary concentrations of certain classes of flavonoids, especially quercetin and isohamnectin, are associated with decreased risk of diabetes in the early follow-up period. And those results are consistent with epidemiological analysis of foods intake and the reduced risk of chronic diseases. Those metabolites, I think, represent the best integration of genetic and dietary influences as well as their interactions. So in conclusion, bioavailability and bioactivity of subclasses of flavonoids differ widely according to chemical structures. Prospective cohort studies have provided some evidence, even though the evidence is not conclusive at this point, on beneficial effects of flavonoids and flavonoid-rich foods. Emerging data from metabolomics technologies to measure metabolites of polyphenols have shown some promising results. Small short-term RCTs have demonstrated beneficial effects of cocoa and some subclasses of flavonoids, such as flavin 3-Os, on cardiovascular risk factors. And there are several important future directions. First of all, we should continue to explore and develop biomarkers or metabolites of flavonoid intake. And this should be done in the context of dietary assessments in large prospective cohort studies. I think the combination of the biomarkers and the repeated dietary assessments in large cohort studies should provide the most powerful analysis of the relationship between those compounds and the health outcomes. And we need replications in various populations, especially with a wide range of intakes of those compounds. And we certainly need much better characterization of bioactive compounds in our food composition database. And finally, we need much larger and more rigorously conducted randomized clinical trials to evaluate the effects of those compounds on intermediate biomarkers. And we should look at both independent and the synergistic effects of multiple compounds. Finally, I want to acknowledge my colleagues who have contributed to the data that I presented today, and Dr. Cassidy, Dr. Rim, Dr. Chi Suan, and Dr. Robert Van Dam. Thank you very much for your attention.